Hello everyone. Let us get started with C++ certification training. So today we are going to look at Introduction to Inheritance. The topics that we are going to cover under this discussion is that what is inheritance, what are different types of inheritance, and finally what are the advantages of inheritance. So let's begin our discussion with looking at what is inheritance. So what is inheritance? Inheritance is a concept where a subclass gets all the feature of an existing base class, which improves the reusability of existing code. So what it means is that, let's say you had a class, let's say this is a car class, CAR, and you want to create a specific kind of a car. Maybe it could be a BMW car, for example, or Maruti car, right? Now, if there is already an existing functionality in car, which can be used by BMW or Maruti, we should inherit the car class, or BMW should inherit this and Maruti should also inherit it. That is what it is trying to say, that when subclass, this is a concept where a subclass gets all the feature of existing base class. So if something is already there, let's get all the features. Now, inheritance provides a method for creating new classes from existing. So these are the new classes. This is an existing class. Creating, for example, you create a scientific calculator from existing simple calculator. So in case you had a simple calculator which was performing basic operations of adding numbers, multiplying numbers, right? Now you want to create a scientific calculator which can calculate square root and other complex functions as well. So you should not rewrite the entire scientific calculator class from scratch. You can create a scientific calculator class and it can extend the existing basic calculator, and then you can continue to add the new functionality. So these new classes contain the data and behavior of existing class. So when we do inheritance, whatever is there will become part of the subclasses as well, the members, which is the attributes and methods. And also it allows us to reuse or inherit data and behavior that already exist, as I just said. Now the superclass is known as base class and subclass is also known as derived class. So you get to use what is already there here, plus additionally you can add more functions and attributes here. So the idea is that you take what is existing, use it, plus add more features. This is a concept of inheritance, and syntactically this is how it looks. We will try it out with an example in some time. So you can say class, name of the class. Here you specify colon, then you specify access type and the name of the superclass. So this is a subclass and this is a superclass with respect to inheritance. So let's take a very simple example to understand what is inheritance. Similarly, we may have different types of shapes that we can draw, such as line, oval, circle, square, and so forth. Depending on our application, we can identify common attributes that all shapes have, for example, color. So let's say I have this hierarchy in place where I have a shape, and there can be different kinds of shapes here, right? So I can define a method color, right? And this color is a method which gives colors to different shapes, that is the subclass of the shapes class. Now, since this method could be commonly used by all these subclasses, smiley, cone, and star. So a good idea is to basically inherit the existing shape class. Smiley is also a shape, cone is also a shape, star is also a shape. So we can reuse what is existing and then additionally add more feature in this individual subclasses. So syntactically, this is how it will look. There is a class shape which is existing. Then we say class smiley, colon, public, and shapes. Same way we do it for the other subclasses. So this is how we basically make use of inheritance. Syntactically, don't worry, we are going to try out all of this with some examples in some time. Now let us talk about different types of inheritance. So we have single inheritance, multiple inheritance, hierarchical inheritance, multi-level inheritance, and hybrid inheritance. So these are different options or different types of inheritance that are available in C++ programming. Depending upon your need and your requirement, you can choose to use any one of them which suits your or rather which solves your problem statement. So feel free to use which one solves your problem statement. So let's move on. So what is single inheritance? So single inheritance, as you can see, the process in which a derived class is inherited from only one base class. This is known as single inheritance. So you have only one superclass and one subclass. Simple syntax is you create a class, you create a subclass, and this subclass extends the superclass. So therefore, since this is a public member, this will get inherited and will be available in the car class. Now, as far as uh, accessibility of the members in the superclass is concerned, we have already discussed this concept in details in access modifiers in other modules. So please feel free to go and refer to that as well. But as of now, please understand that in single inheritance, there is a single subclass and a single superclass with respect to the concept of single inheritance. Then next is multiple inheritance. So what happens in multiple inheritance? The process of deriving a new class which inherits the attribute from two or more classes is known as multiple inheritance. Now here you have a vehicle, right? A vehicle could be inheriting a car and a bus and a train. Maybe, for example, this is a hypothetical scenario or an example. So maybe vehicle will get the attributes or methods of car and also bus and also train. This concept is known as multiple inheritance, and syntactically you say class. So you already have the three classes, superclasses. Then you say class vehicle colon, you specify the access modifier and the name of the superclass, comma, again access modifier, and then the superclass bus, and then again access modifier and the superclass train. Now, what is the significance of this access modifier? This has already been covered in a different module, access modifier. Please feel free to refer to that module. But for now, we are talking about a single class inheriting methods and attributes from multiple classes, which is a concept of multiple inheritance in C++. Then next is hierarchical inheritance, the process of deriving more than one class from a base class is known as hierarchical inheritance. So we have more than one class, as you can see, which is extending or inheriting from a vehicle class, right? Syntactically, you create a class, and then what you can do, there is a class which is extending vehicle, car is extending vehicle, bus is also extending vehicle. So this is a concept of hierarchical inheritance in C++. The next is multi-level inheritance. As the name suggests, there are different levels. So there is, if I call this as level 1, 2, 3, then 3 extends 2, which in turn extends 1. So the process of deriving a class from another derived class is known as multiple inheritance. Syntactically, car is extending four-wheeler, right? So this one, and four-wheeler is extending vehicle. So what will happen, the attribute which is here, let's say there was an attribute, public attribute A, variable A, which came here, and if you have publicly extended the class, then as you can see, I have used public keyword here, then A will be available from vehicle to four-wheeler, and again if we are doing public inheritance, this again will be available here. So this way we achieve multi-level inheritance in C++, meaning that depth or the level of inheritance is when one class is extending another class, which in turn is also extending another class. So this is a concept of multi-level inheritance in C++. Then the next one is hybrid inheritance. As you can see, the combination of more than one type of inheritance is known as hybrid inheritance. So you have basically a car and a bus, which are actually vehicles. So car is extending a vehicle, bus is also extending a vehicle. So car is extending a vehicle here. As you can see, car extends vehicle, and bus is also extending a vehicle. Now you have a fair class, right, which in turn is extending car and a bus. So basically this kind of inheritance which is available in C++ is known as hybrid inheritance. Now, as I have already told you, you might be curious to know that which one to use when. So as such, there is no specific rule or guideline, but depending upon the problem statement that you are trying to solve, you should use either one of them. So for example, let's say if you have this particular inheritance, let's say multi-level. So this is a nice example, right? So you can have a vehicle at the top in the hierarchy, right? Under that you can have a four-wheeler. Under four-wheeler you can have a car, right? Under car you can go to one more depth, which is, let's say, Maruti, for example. Similarly, under vehicle you can have two-wheeler also, two-wheeler. Right here you can have bike. Underneath you can have different brands of the bike. So this is basically you are trying to achieve multi-level inheritance. So this way, depending upon the problem statement that you are trying to solve in your program at any given point of time, you have to decide to choose a most suitable inheritance concept to solve your problem. Now, what are some of the advantages of inheritance? So basically, the main advantage of inheritance is that we reuse the existing code that might have been created by other developer. So as I had told earlier, you have something in place, right? So let's say you are trying to construct or build a new car, right? So you don't want to build a car from the scratch. Let's say there was already an existing car features or functionalities available, right? Then you are creating a new car, and let's call it, for example, Zoom car, right? I mean, Zoom, we already know, is available as a rental car. So if you are trying to create Zoom car, what you can do is you can take the existing car, extend that, and maybe you can add more additional features, functionalities. So basically we reuse what is existing. That is the emphasis or the main concept of inheritance. As the name suggests, inheritance means you inherit what is existing or what is already there, like you inherit features, attributes from your parents, right? Now the child class can inherit superclass to reuse what is existing and add newer functionalities to the base class to enhance, upgrade the existing functionalities. So as I said that when you inherit, you get what is available in car. Of course, what you get will depend upon the access modifier in this class. This concept of access modifier I have covered in a separate module of access modifiers. Please refer to that. But what is there in car you get in Zoom, and plus additionally you can add new features that you want to enhance a car class and then build a Zoom car of your choice. For example, BMW might extend a car class and enhance its engine power in subclass to give a better performance, right? So as I have already told you, we are basically trying to achieve reusability and then extend the functionality by adding more features and functionalities in the subclass. So these are the major advantages of inheritance in C++. So to summarize this discussion, at the end of this session, you should be able to understand the type of inheritance and the use of inheritance. So in summary, we have looked at what is inheritance, what are the different types of inheritance, and we have looked at some of the advantages of inheritance in C++. That's all in this discussion. Thank you so much for your time.